All right, so today we're going to be looking at sine, cosine, and tangent again. Our main goal is to look at the unit circle and get a bit more proficient in that. And to do that today, we're going to work a little bit with arc length and circle sector. We are going to work with trigonometric identities, some fairly simple ones, using the unit circle to look at the symmetrical properties of angles and sine, cosine, and tangent values. And we will also have a go at solving some very simple trigonometric equations. Okay, so first up, a little bit of a review. So the radian angle measures that we've been looking at. Remember that in the coordinate plane, an angle in standard position has its... Wait. Let me try and do that again. Let me just pause a second. Good. All right. So, thank you, Sahan. Yeah, so in the coordinate plane, an angle in standard position has its vertex at the origin. That's the vertex of the angle. One of the rays lies along the positive x-axis, and that's called the initial ray. So I've seen a few questions that they focus on this terminology. This is the initial ray. It should lie along the positive x-axis. And then when we rotate to the terminal ray, we define an angle in standard position. So there's some really useful words here: standard position, the terminal ray, the vertex, and the initial ray. Make sure we know these particular words. So if we rotate counterclockwise, that's anti-clockwise, we get a positive angle. If we rotate clockwise, then we can get a negative angle. So you can define an angle by rotating in the opposite direction. So what we also see from this is we have a periodic behavior happening. So for instance, I can rotate round to here, and this might be 2 pi over 3. So this could be 2 pi over 3 radians at this particular point. How much is that in degrees? Oh. Don't times by 2 first. Start by dividing by 3. So yeah, this needs to be 120 degrees here. Could there be any other angle that lies at this particular point? Could there be any other angle that lies at this particular point? Work that number out. Work. Sorry. Are you in degrees or radians? Okay. So can we have that? What was suggested is that you can also get there by going 180 here and then another 60 there. So if we rotate in this direction, this would have the equivalent of it being negative 240 degrees. What would that be in radians? So to show you how to do that in radians, we know that this one is negative pi over 3. So 180 is pi, so that's 3 pi over 3. That's 3 pi over 3. Pi, you can always turn pi into 3 pi over 3, 4 pi over 4, 6 pi over 6, and so on. So we will convert the negative rotation of 1/2 into 3 pi over 3, and then we keep going one more pi. So this would give us minus 4 pi over 3. Minus 4 pi over 3. Okay, one last one. This angle here could have a positive angle that's greater than 2 pi. What would that be? this angle here could have a positive angle rotation, which is greater than 2 pi. What would that be? If we were to start here, rotate round, and then end here at this point. Yeah? So we are going to do 2 pi over 3 plus 2 pi. Purvis says we do a whole rotation, we get this. What's that as a fraction then going to be? Don't forget that convert your pi in because we want to have a base. We want to have a base of 3, a denominator of 3. So we take this one and we multiply it by 3 over 3. This gives us 6 plus 2, so 8 pi over 3. You'll benefit from a lot from practicing these type of fraction calculations by hand. It becomes easier with time. It's not easy to begin with. All right, so when we measure angles, what we're measuring, the way that we measure an angle is that the angle is the arc length divided by the radius. So the angle measure, the measure of the angle is equal to the arc length divided by the radius. Now, when the arc length and the radius are the same, that's what we get, 1 radian. So if the arc length and the radius are the same, you're dividing 1 by 1, or you're dividing the same number by the same number, and you're going to get 1. And that's how we define 1 radian. So what is the arc length for a semicircle? What is the arc length for a semicircle? What is the arc length for a semicircle? Okay, what's the formula for the circumference of a circle? That came out really quickly. Notice how that came out really quickly from you. Most of you repeated as soon as I said, what is the formula for the circumference of a circle? So the circumference. This formula has been memorized by a lot of you. 2 pi r. So what is the arc length of a semicircle? Pi r. Now see how much quicker it came out the second time? See how much quicker it came out? So what is the angle measure for a semicircle? If the arc length is pi r, and we divide by r, look, it's pi. I keep saying, remember that, oh, you didn't like the line. Remember this one. Remember this point over here. Helps you with a lot of problems. So the arc length is pi r, and how did we calculate the arc length? Well, we took the circumference of the circle and we multiplied it by the fraction of the circle that we're considering. So when we look at sectors and segments here, little diagram to help you with a bit of terminology, we can see a few words. This is what we call a sector. The arc length of the sector is here. This is the minor arc. This is the major arc or the major sector. Generally, if it talks about a sector, it's always referring to the minor sector. We're always referring to the minor sector. But remember that there's always another arc and another sector. Every time you have one, you have two. Same with an angle. Every time you have an angle, you always have the reflex angle as well. Which one are you talking about? We normally always assume the smallest. So we're asked to show that the arc length, L, is equal to theta r. So let's have a go at that one. How do we do this? We've got L, which is our arc length. That is going to be what? Remember how we did it here? It's like what fraction of the circle is the arc? What fraction of the circle? And in the semicircle, it was half. In the semicircle. So what fraction, if you have theta here, What fraction of the circle is that? What?
Yeah, the angle over 360, that you times it with the whole.
If we're working in radians. Yeah. So the first bit is this. We had a couple of answers. So it's basically the angle. People started with angle over 360. And this will give us what fraction of the circle the angle represents. And then I asked them to correct that and write it in radians. So we changed 360 into radians. So this is the fraction of the circle. And what's the whole circumference of the circle? What's the formula for the whole circumference of the circle? 2 pi r. Can we simplify that? Bloop, bloop. So in radians, this is the formula for the length of an arc, theta r. Have a go now for yourself at doing the same for the area of a sector. Use the same approach. Let's have a look. Try and not mess this up. So we need to show that the area of the sector, so I'll just do a left-hand side, is equal to area. And that is equal to our fraction again, multiplied by the whole area of a circle. What's the area of the circle? It's pi r squared. And then what can we cancel? We can cancel a pi. Is that it? Yeah, that's it. This gives us a half r squared theta, the right-hand side. So those are the two formulas. Let's have a go at using them now.
So can you please go back on the slide? The slides.
There's no slide, there's just a chair.
The slides on the computer.
All right, we got the formulas. Have a go at these two questions. Let's have a look. Okay, so we need to find the arc length AB. So the length AB is going to be equal to theta r. Theta is 3 pi over 4 times 8. That's going to give us 6 pi units. Oh, no, it's not units, it's centimeters. So B, the area. The area is a half r squared theta. So that's a half times 8 squared times 3 pi over 4. So half times 64 times 3 pi over 4. 2 times 4 is 8, so 64 divided by 8 is 8 again. So 8 times 3 pi, 24 pi centimeters squared. Any questions? All right, so the unit circle. Have a go at using the unit circle to determine which quadrants sine theta, cosine theta, and tan theta are positive and which are negative. How do we do this? Well, remember, the important thing to remember is that this vector here is the x-axis, is the x value, which equals the cosine of theta. This vector here is the y value, and this is sine theta. As we rotate this point around into the different quadrants, do we know which quadrant is which? Yeah. So this is the first quadrant, this is the second quadrant, this is the third, this is the fourth. Take 2 minutes for that one. Come on. Okay, so in the first quadrant, the x value is positive, the y value is positive, and then the gradient, the slope of this line is positive. So all three of them are positive here. So here, all three of them. As we move around into this quadrant here, we notice that the cosine values, which would be the x values, will be negative. So the cosine values in this direction are going to be negative. The sine values are going to be positive, and the slope of the line, look at the slope of the line, that's negative. So the only one that's positive in this quadrant is going to be the sine values in the second quadrant. In the third quadrant, the x values are negative, the y values are negative, we're down here, but the slope of the line is still positive. So tangent is going to be positive here. And in the fourth quadrant, we get a little line going down here like this. Here, the x values, like that, they're positive, but the y values are negative. So the cosine values are positive, the y values are negative, and the slope is negative. So it's only going to be the cosine. So a lot of people remember the acronym ASTC, which stands for All Students Take Calculus. And that helps you remember it. All students take calculus. I think it's easier to work it out than to try and memorize some acronym, but wherever floats your boat. Okay, use the symmetrical properties of the unit circle to determine the following identities. So for instance, if we wish to draw this first set here, where is pi minus theta? So if we have an angle theta here, we're rotating in that direction this much. If we have an angle pi, we're there. So if we go across to here, this is pi. If we come backwards by theta in this direction, we end up with a particular point here. Notice the horizontal line here, the symmetry of this. So in this first, in this first one, the sine of theta, the sine of pi minus theta is equal to sine theta. That is because the coordinates of this point are going to be minus cos theta, comma sine theta. So this coordinate here, which is a reflection of this coordinate there, is minus theta, comma sine theta. So the sine value is, so the sine of that is sine theta. What will the cosine be? Minus cos theta. And what will the tan be? Minus tan theta, because tangent is negative here. This is, let me take a little bit more on that one. You can always fall back on sine theta over cos theta. In this case, the cosine is negative. So that's where the minus is coming from. Have a go now using the unit circle to do the other two sets. Okay, so our second set are going to be when the point is reflected down to here. So in this particular set, we're going to be reflecting down to there. What's the coordinates in this point? It's going to be minus cosine theta, comma, minus sine theta. Here we have the angle theta, so we rotate over, firstly we rotate over to pi, and then we rotate another theta down, and it brings us to this point. So this point is symmetrical. We've got a vertical line here like this one, so they have the same cosine values, but the sine value is a reflection. So what we're going to get is the sine value here is going to be minus sine theta. The cosine value is minus cosine theta. Remember that the tangent is positive down here, and a negative divided by a negative will make it positive. Our last one is going to be there at, it's going to be here at this particular point. So our last one is down here. The coordinates of this point is cosine theta, comma, sine theta. Sorry, minus sine theta. So this one is going to be minus sine theta. This one is going to be cos theta. This one is going to be minus tan theta. Can we move on? Have a go now at finding the sine, cosine, and tangent value of 225 degrees. Right. Okay, so 225. What we want to do for this one, to solve the problem, let's start off by sketching a unit circle. .225, which quadrant is that one going to lie in?
3.
That's going to lie in 3, here, like this one. So this is, we're working in degrees here, so this is 180 degrees. How much past 180 is 225?
45.
So this is 45 past. So we are going to need to know our exact value table, a little bit of it. So the sine, cosine, and tangent. You can do a little extract of it. We don't need the whole thing. So at 45 degrees, what is the sine value? I shall use the root 2 over 2. And the cosine value? Root 2 over 2. And the tangent value? 1. So it's going to have these values. Which one is going to be positive? Which one is going to be negative? So the sine of 225 is going to be minus root 2 over 2. The cosine of 225 is going to be minus root 2 over 2. And the tangent of 225 is going to be 1. Done. Have a go at this one. Click, click. All right. So what have we got? We've got the cosine of theta is 0.5. So how do we solve it? We start off by drawing a unit circle. Start off by drawing a unit circle. Figure out what information we have. So let's try and make that a circle. There we go. So we know that the cosine of the angle is 0.5. So 0.5 is there. 0.5 is there. If I draw a vertical line here like this is the line where x equals 0.5. So the angle that we're after has to intersect this, either here or here? We're also told that the tan is negative. So this theta is either here or here. We're told that the tangent value is negative. So all students take calculus. So the tangent value is negative here in this quadrant. So we have to be there or there. Well, we can't be up there because that doesn't make sense. So our angle is this here. Now, we need to use the exact value table. So if we pull up the exact value table, we've got a little bit of the exact value table: sine theta, cosine theta, tan theta, and here's theta. We know that this one is 0.5. So what's the angle going to be from the exact value table? This one's 60 degrees. This one's 60 degrees. So what is the sine value of 60 degrees? Root 3 over 2. And we have, sorry, yeah, that will do us. Right. So if the angle is 60 degrees, this is minus 60 degrees. So we've got theta is equal to 360 degrees minus 60 degrees, 300 degrees. We've got the sine of theta to be equal to root 3 over 2, and then we use our all students take calculus, so sine has to be negative, so it's negative. Done.
How do we know it's 300 degrees and not negative 60 degrees?
Yeah, typically I'll answer a question in the first period, which is between 0 and 360 degrees. If I wish to have all of the possible theta, then I would add n 360 degrees, because it's a periodic function. If you remember back to topic 1, 3.1, so we need to know what the period is. The period is 360 degrees, so it's going to be 300 plus n 360, where n is an integer value. And then this would be the complete solution. Okay, have a go at these two questions. Okay, let's have a look. All right, so let's kick off with the first one. Sine theta equals a half. To solve this one, I'm going to start by, how will I start? I will draw a unit circle. Okay, so the sine value, is that the x value or the y value?
Y.
And a half, is that positive or negative?
Positive.
So a half is here, which means we have to find a y value like this one. So we know that y equals a half. So we've got a line coming up like this one, which meets that, and that will give us theta here. We get a line here, and this one is minus theta, because we go that way. These are our two possible angles. Next, we move over to the exact value table. Let me pop the whole exact value table up. So we've got x, sine x, cosine x, tan x. We've got pi over 6, pi over 4, pi over 3, pi over 2. Sorry, I missed 0. I missed the zeros, and 0. So this gives us 0, 1, 0. This gives us a half, root 2 over 3, root 3 over 2, and then 1. This gives us root 3 over 2, root 2 over 2, sorry. Got those messed up. Root 2 over 2, root 2 over 2, a half, 0, 1 over root 3, 1, root 3, undefined. So if the sine value equals a half, we are looking at that. So what is the angle? Pi over 6. So this one implies that theta equals pi over 6. Now we have a second possible angle created over here. Remember that this here is pi. How can we write pi as being something over 6? This is 6 pi over 6. So if we take 1 pi off of that, how many pi's are left? 5 pi over 6. This is our answer. Yes? Because here at this point, this is 6 pi over 6. But we want to be at that point there, which is, we have to take away theta from 6 pi over 6. And theta is currently 1 pi over 6. So we're taking 1 pi over 6 away from 6 pi over 6. Let's repeat this now, a little bit quicker, for this one. So we start off, we draw our unit circle. Root 3 over 2. Is this positive or is this a sine value, an x value, or a y value? It's an x value. Why? Why is it an x value? It's cosine. Is it positive or negative? So it's going to be about there. It's going to be about that. Minus 0.866. So we draw a vertical line like this one. This is where this is where x, this is the line where x is equal to minus root 3 over 2. We get two possible angles for that one. One here and one here. Now none of these are in the exact value table, but they are in symmetry with this one here. Now this one here is in the exact value table. Which one is it? Pi over 6 again. This is when the cosine value is root 3 over 2. So this would be pi over 6. So this angle here is pi over 6. What about this angle here for this one? Well, we're going to get a minus pi over 6 there, and we're going to get a plus pi over 6 here. This is 6 pi over 6, so the cosine of theta implies that, equal to minus root 3 over 2, implies that theta is equal to what? 5 pi over 6 and 7 pi over 6. So, because of the question. So the question told us that it would be this. So we're going from 0 to 2 pi. So we're only going in the principal rotation. And that gives us these two answers. No. Last question. Have a go at solving this one. Actually, no, I'll just go straight into it. We've got 10 minutes left. Let me go straight into it. Guys. All right. So What we want to do for this one is, this is a disguised quadratic equation. So one way to solve it is to let t equals sine theta. So I've got 2t squared plus t minus 1 is equal to 0. I need to factor this. So 2 times minus 1 is minus 2. So taking the first and last coefficients. This can be produced by the product of 2 times negative 1. And I choose this because 2 plus negative 1 is equal to 1, which is the middle coefficient here. So factoring that, I'm going to have 2t squared plus 2t minus t minus 1 equals 0. Factoring out the 2t, I get t minus 1. Factoring out a negative 1, I get t plus 1. And then this is going to give me the factors 2t minus 1, t plus 1 equals 0. And we get 2 sine theta minus 1, sine theta plus 1. So a little bit of quadratics there on that one. And we come to this particular point. Solving that, either the first factor is 0 or the second factor is 0. So the first factor being 0 gives us 2 sine theta minus 1 equals 0, or sine theta equals a half. Solving that one using the exact value table, that was pi over 6 or 5 pi over 6. So this implies that theta equals pi over 6, 5 pi over 6. Our second factor is that sine theta plus 1 equals 0. So sine theta equals negative 1. Use the unit circle for this. The sine value is the negative 1. That's this point here. This point here is at 0, negative 1. So this would be 3 pi over 2. So 3 pi over 2. These are our solutions. Okay, that's it for today.